Talk about this. Today's the 29th, right? Yes, Andrew. Good time. Absolutely not.
You get it. Okay.
So today is the 29th, and we're going to do inverses again, but this time we are going to find the inverses of rational functions. I know that one particular student who's not here will for sure be watching this video. In fact, I know both the students that aren't here today will be watching this video. Both of them, they're very good about that. And that one, yes, right there in particular, will undoubtedly find a shortcut for this. And some of you might throughout the lesson as well. It's, I don't know if I don't really want you going there, but if you do enough of them, eventually you will start to see some patterns in what the function looks like and what the inverse looks like. So I would like it if you would kind of work them out. And if there comes a point where you feel saturated, like I get it, and you want to start looking for clever workarounds, then of course that's fine. So you'll see there's some patterns to be observed. So 6 examples, like Zach called. So our first function is f of x equals 5 minus 2x over 2 plus 3x. By the way, it's about time I cross this bridge with you because this is going to be a big part of how we spend our time this year. A rational function is not just a function that has a fraction in it, to be clear. So like an exponential function is not just any old function that has an exponent, okay? To be exponential, your exponent has to contain a variable. To be a rational function, the bottom of your ratio has got to have a variable. So I don't intend to mention this too much more beyond this point. I just want to make sure you're clear that like if I put a function up here like this, that is not a rational function, okay? Because the bottom does not contain a variable. So the rational, by definition, means you got variables in the bottom. And honestly, even if you didn't have a variable in the top, so like if I flipped those and I said 3 over x minus 4, that is now a rational function. The top is irrelevant. If the bottom has a variable, it's called rational, okay? And we'll study the graphs of rationals, and it's a fun like 4-week unit, graphing rationals. Anyhow, let's get to it. So this is a rational function, and we're going to invert it. So the steps don't change. It's just there's a little bit of different looking algebra throughout the course of the problem. So step one, let's go ahead and do an XY swap. So we're going to do x equals 5 minus 2y over 2 plus 3y. Do you notice anything right away that's going to potentially be troublesome?
We're gonna have to like bring a variable to the other side. Y or square.
Yeah, you're still not quite seeing maybe what I want you to see. Like, what are we about to try to do?
Negative y on top of the y plus
Be less specific. What is our goal right now?
get y by
To
itself.
get y by itself. That's what I wanted to hear. And the trouble with that is there's y's in multiple places.
Yeah.
So listen, this is a good trick. I probably showed you some variation of this at some point in our time together. But when you have a variable that you're trying to solve for and it's in more than one place, usually getting them onto the same side and factoring out as a commonality is going to be the strategy. So that's where we're going to go. But step one is algebra 101, which is to multiply both sides by the bottom. We don't want there to be a top and a bottom, so we're going to multiply both sides by 2 plus 3y. So that's always going to be step one, is to say, hey, can I stop this thing temporarily from looking like a rational function? Because we want everyone to be up on the open level playing field so we can move things around and shuffle. So on this right-hand side, the 2 plus 3y's are going to cancel, and we're going to be left with 2x plus 3xy equals 5 minus 2y. And we're far enough along in our math careers that you shouldn't feel stress about that. I distributed the x through the red parentheses and then did a little bit of rearranging. Like no one says x2, right? And no one says 3yx. Like we want to alphabetize, clean those things up as we go. So here it is. This is kind of the big thing. And I say we may not need all these examples because you'll get this pretty quick after a couple. The y is in 2 places. And so that's a problem. And So step one is to get the y's onto the same side and make sure that there's nothing else on that side. To me, the most efficient way to do this is to leave the 3xy here, bring the 2y across, and then boot. Sorry about that little extra mark there. And then boot the 2x to the other side. And you can leave it as 5 minus 2x, or you could write it as like negative 2x plus 5. That's all just fundamental algebra mechanics stuff, right? We're far past the point of showing how that happened. We're just moving things across equal signs at our leisure. And the reason that's such a powerful trick as you go on to like college math classes, the reason that's such a powerful trick is it enables you now to turn two things into one by factoring. And so you'll notice that these two terms on the left, the red one and the yellow one, both have y's in them. So what do? We remove it. We actually undistribute it. We GCF it out the left side. So we're going to take the y that we want to be our target, and we're going to undistribute it from both of these terms, leaving the left side now as y times what?
3x, 3x plus 2.
Correct. And through the magic of a little bit of creativity and some pretty basic algebra, we now have y as a single copy of himself, which is what we want. And having said that, we're one step away from done. What do we do? Divide, right? And we're going to divide by that whole big chunk. That big thing that's globbed onto my y is basically like adios, amigo. We just divide by that whole thing and jump right to it. And you can just state the answer as, okay, f inverse of x is equal to 5 minus 2x divided by 3x plus 2, like this. So I'll say what I said before. I don't think we need all 6 examples, but I certainly would be remiss if I assumed that one was enough. So that's our first one. Let's do another. So the idea is unrational it by multiplying, shuffle your y's onto the same side, factor it out, divide. Like that's going to be sort of a rinse and repeat cycle here. All right. Next one. Let's rename. Let's call this function g of x.
We need all junior high volleyball players to be released from class.
So, oh God, I was just wondering. I actually I can say this on the recording. I foolishly thought to myself, we're going to make it through this, and not one of these people is going to pretend to be a junior high volleyball. And there was about 1 second where I thought we made it, and then I was brought back down to reality. Thanks, boys. So the function g of x is going to be x minus 4 over 6x. So we're going to do the swap. We're going to rename our y as x, and we're going to rename our x's as y's. And the algebra is pretty, like I said, pretty rinse and repeat. This is a one-day thing. This isn't something that you're going to get time to work on like over the next few days. It's pretty straightforward. So, all right, let's do the algebra. What do we do first?
Multiply by 6y.
Multiply both sides by 6. It's one of those ideas I tried really hard in our first year together a few years ago to get stuck in your head is that C fraction, kill fraction, C fraction, kill fraction. So, and you can multiply by whatever you want to make a fraction go away. So we're going to be left with 6xy is equal to y minus 4. Next step. Get the y's on the same side. So like I'm going to pull the y to the left. I think that feels to me to be the cleanest. So I'm going to have 6xy minus y equals negative 4. And then the magic happens in this step. This is the powerful tool that you want to have. The ability to turn two things into one by factoring is pretty cool. So pull that y out, and I'll write it in yellow. So there's our target. The y that we're trying to get by himself is factored out. What's going to be left in the parentheses? Perfect. 6x minus placeholder 1. Nice job on the 1. And then final step. Divide. And instead of writing y equals again, when you're just going to have to copy it over, let's just jump right to it and just write g inverse of x equals. And what is the answer going to be?
Negative 4. 6x. 6x.
Yeah, and listen, since there's tests out there that are multiple choice, this answer could be written three different ways. The negative could be on top like this. Someone, for some weird reason, could have moved the negative to the bottom, and then the bottom would say negative 6x plus 1. And someone could also pull the negative outside and just have it be the negative of 4 over 6x minus 1. So if you were taking a multiple choice test, bear in mind that those are all possibilities. People like me, generally, I like the negative pulled out, but like, um, I don't write multiple choice tests, so who really cares? I'm gonna skip a couple. I'm gonna head to the last couple because I think there's going to be a little redundancy in these next. So let's try this one. Let's have this function be in honor of Zach and Zane. This will be z of x. Our function's name is z, and the function is 9 over 2x minus 7. Full disclosure, I didn't actually work these out. I just kind of concocted them onto a note card. So I don't know if anything new and meaty is going to happen here or not, but let's go ahead and do the old switcherooski. So we're going to have x equals 9 over 2y minus 7. Next step. Multiply both sides by.
The bottom.
Yeah, and I want to tell you this because I care about you. To write your multiplication like this is unacceptable. What have I forgotten? Parentheses. Okay, when you multiply by a quantity that has more than one term, it's imperative that you parenthesize it to make sure everyone's clear on what your intentions are. If I was just multiplying by 2y, yeah, whatever, who cares? But having that closed in is important to say all of this is my multiplier. On the right side, I'm going to cross off these. And then what's my left side going to say? Perfect. Yeah. So here's an example of one. I'm just making sure we did the full swap. Here's an example of one where there's no like consolidation necessary, right? There's only one y. The algebra by this point in your life should be like rudimentary. To get y by itself, what would you just instinctively do? You don't need to pull anyone out, really, quite frankly. Let's just get this done. I want you to understand that there is only one term that has y, and it's in that green box, right? So we can harken back all the way to the Algebra 1 days. Just follow your instincts. Who has to move first? The 7x has to go. So we're just going to go 2xy equals 7x plus 9. What's the last thing we would do? Divide by 2x. So I'm actually glad we did this example. I wasn't really sure what it would produce, but it was a good opportunity for you to see that we don't always have to do the pull out trick because we don't always have our y in more than one place. So this was pretty simpler, maybe. So this is going to be z inverse of x, and it's going to equal 7x plus 9 over 2x. And I do want to do this last one just because I think there might be a little something, something, but again, I'm not sure. So maybe it'll surprise me. And then after this, we'll be done. And then we'll get our things after this and head down and work nicely, quietly, productively on Delta Math in the comments. Sound good? Rad. Okay. All right. So we have, let's do for Sadie, we're going to do S of X. And the function will be negative 1 over 3 minus 4x. Good, good. All right, so let's do the old swaparooski. So step one is, of course, to switch your dudes. And you can see that, like the last one, we're only going to have one copy of y, right? So this, I bet this will wind up feeling a lot like the last example. And because if the right side of my function doesn't have more than one x, then there's probably not just going to magically become a new one, right? So let's do x equals negative 1 over 3 minus 4x. Oh, 3 minus 4y. Apologies. I made it through the whole thing without forgetting that, and then I did it right there. Darn. All right, fourth verse, same as the first. What do we do?
Multiply by.
Yep. and they're going to cancel. So again, mechanically, this is awfully rinse and repeat, sort of, right? Just looking for any little nuancy differences, but it feels like we probably covered everything. What's my left side going to say? Zoop, zoop.
3x.
Love it. And that just equals -1. So you see, again, the moral of the story is because there was no variable up here in the green circle, then there's not going to be multiple copies, right? So this is nice. So just follow your algebraic instincts. How would you feel if I wrote this? Just curious. Fine. And we're to the point where, like, if I did that in Algebra 1, I probably would have gotten some flack from you guys or from somebody, but you understand, like, it's all relative. It doesn't matter. I wanted to move the 4xy so he'd be positive, and then I thought, oh, how convenient. If I then have to move the 1, he'll become positive too. It's a positivity fest at this point. So what's the last step? We just divide by the 4x and we're out. So our final answer is going to be S inverse of x is equal to 3x plus 1 over 4x. And if you haven't been hunting for it, it's okay. You'll see when you get right down to it that there's a lot of relationship to be noticed between the original function and the inverse. If you haven't caught it yet, there's like fives. If you see a 5 and a 9, your answer is probably going to have a 5 and a 9. It's just they're going to move and turn positive and negative. And I don't even know if it's worth the effort to look for like a shortcut like that. But like I said, it's up to you. So
Is there a rule? Like,
nah,
because they're all random, but it's just the same number.
I know it does. And is there a rule? I honestly, maybe. I don't know. Like if you want to search for one, you're welcome to. But at the end of the day, what you'll figure out is like these don't take a long time anyway. So that is that. I'm gonna stop this recording. I'm gonna pack up and get down there. I'm gonna lock up my room too. So make sure you take your stuff with you. Okay. So give you a couple minutes, pack up, and then we'll head down and work in the commons.
Is there a way to charge in the commons or no?
I believe there are electrical outlets in the commons. Yes.
Yeah. On the side of the
Is
station.
my computer is mad.